Welcome everybody. Today I have the pleasure to show you what JMP is about and what this means for academic users. This webinar is designed with professors in mind teaching with data. But if you are not teaching, maybe not academic, or if you know JMP already, don't hang up. We will have some useful information for you as well. During this hour, I will spend most of the time with some JMP basics, covering basic navigation in JMP, how to get data into JMP, looking at some platforms for summarizing and graphing data, giving some tips for new users, and looking at some sample analyses. At the end, I will also show you some free resources before wrapping up. So, welcome to JMP, which first version was released by SAS Institute in 1989. After almost 3 decades, JMP is still very different. As you will see in a minute, it is more like a journey, what we call statistical discovery. On one hand, JMP is very easy to use. This is very important for teaching, and this quote from Oxford confirms it very nicely. On the other hand, and important for researchers, JMP has powerful tools built in without limits. You will get all development tools for custom apps, a dashboard builder, and the JMP scripting language JSL, which also integrates JMP with other software. Let us jump into a first example. And by the way, on the left you see a JMP journal. You can download this journal in our academic webinar library and use your own or a trial version of JMP to explore everything on your own later on. And all academic site licenses give you access to the latest version of JMP Pro for Windows and Mac. On my Mac I use JMP 14.1, actually JMP Pro 14.1, launched earlier this year. The starter window is a more informative menu for new users. You get categories with an easy access to platforms for reliability, DOE, or table tools. And you can also see the JMP Pro specific platforms like Genrec, or the Pro features like enhanced neural networks or bootstrapping. Now lay back and see what is JMP. Welcome to the big class families, one of our sample data sets, with family data in 12 variables or columns for 40 kids from a school class stored in 40 rows. As soon as the data is ready in JMP, you choose the type of analysis on high level. So, for instance, univariate statistics using distribution, or bivariate using fit y by x, or a multivariate method like fit model, or predictive modeling tools, specialized tools, or any other multivariate method or clustering. Or choose a graph type and use the interactive graph builder, or create a bubble plot, a 3D scatter plot, or other graphing tools. Let me explore this data set by calling the first from both menus, the distribution from the Analyze menu and Graph Builder from the Graph menu. So distribution is for univariate statistics. This is the launch window, and I have to assign the variables, the columns I want to analyze, into roles they should play in this analysis. I select options like histograms only and action. OK. This report shows us bar charts for our categorical variables, name, age, and sex, and histograms for the continuous variables, height and weight. They are linked, so I can select data like the kids with a higher height, the taller kids, and I see the same subset in the other variables as well. So I can look at the kids with a high weight, for instance, and I see that there are some kids which are 12 years old, but no kids at 13 years old. If I want to look into the 12 years old group of school kids, I can double click that bar and I get a subset with all the kids which are 12 years old. The red triangles or hotspots are your best friends in JMP. So for instance, on the age output, I can add a mosaic plot. Or for the sex bar chart, I can add counts. For continuous data, I can ask for a normal quantile plot. Oops, there are two Roberts in this data set. Let me increase this to see this here. There are two Roberts. So, but that's maybe not a problem. So let me remove the name bar chart and look at the remaining ones. I can also use the top red triangle, for instance, to stack all outputs, and I collapse all of them except weight. So here I can ask for an outlier box plot, and we see that there is one extreme weight, and I can point to that data point and see that this is Lawrence. I can also add a normal quantile plot again, or I could fit a continuous distribution. I ask JMP what's the best distribution fitting our data, and the winner is a log normal distribution, also shown graphically added on the histogram. If you're interested in a normal distribution, I can add that one as well, shown in red. And we see the details here for the fit. And there's another red triangle where I can ask for the goodness of this fit. To answer the question, JMP does a Shapiro-Wilk W test. And this number here is a p-value. And this is not significant, so there's no evidence to worry about normality of this of these data. Let me close the distribution output and take the other exploratory tool from the graph menu, which is the graph builder. So this is an interactive platform, so I can drag and drop my variables to this palette or work zone, and I use weight as the Y and height as the X. And we see a smoother. I could also change or even switch to a regression line and a confidence band for the fit. And I can use sex to maybe wrap it or overlay just color to see the output for male and female kids separately. Again, there's a male kid with a high weight, and this is again Lawrence, who can be identified in this graph very easily again. I can start over, and now I put weight on the y-axis again, but I use the categorical age on the x-axis. So we get some jittered data points in groups, and here I switch to box plots, and we see an extremely high weight in the 15 years group, and this is one of our two Roberts. Again, I can use SACS and maybe use it as overlay or just color. So if I maybe switch to a contour plot and add the data, so now the female and male points are colored by sex. When I'm done, I click Done. I can maximize the output if I want to present this maybe, and I can still multi-select data points or even pick the male or female kids from the legend. There's one other tool, because if you look at the columns, you see one special column which is shown as unstructured text. And this column contains illness reports in text form. So I can use text analytics to get a better idea about what type of illnesses have been reported. So that's done by a text explorer. I use the text column for the analysis, and then I see the dominant terms and phrases in my corpus, but I can also add a word cloud to see what this is about. So there are many headaches and also some stomach problems reported. If I'm interested to see more details about the stomach problems, I can select it again and look at the texts and the context information. I can also dig deeper and run an analysis like a semantic analysis, and this shows me the documents and the terms in two-dimensional spaces, and I see that these terms go together, so they are fright and stomach and upset. So this is one group of terms which are used together in our corpus. Let me close this again and proceed to some basics in JMP. So regarding the navigation, we already saw the JMP starter menu, which is a nice alternative for new users. The home window is the central point to navigate within your JMP files and open windows and reports. And the application menu, that's the menu shown on top of my screen on a Mac and on top of the home window and other windows as well on a Windows machine. The next is about data and metadata. So first about the rows. So we see that we have 40 rows in this data set. And let me maybe select the kids which are taller than 66 inch. So I add this condition and now I select them. So now 6 rows have been selected. and we see them here. So that's one state. But I can also hide these rows. That means don't show them in any graph anymore, and I can also exclude them, which means don't use them in any analysis. And these are also shown by icons on rows and also on the row states panel as excluded and hidden. And I can switch it back so to get them back into the data set for my analysis. Also, columns can have states. So here we have the name column, and we see that the label state is used to use this information for labeling data points. So you will see the name instead of just the row number. But maybe more important are the modeling types. What you see by icons on the columns in the columns panel. I can right click and ask for a column info for age. And here we see that age has numeric values, and the modeling type, the scaling of our variable, is set to ordinal. And that's the green icon we see here. If this is numeric, it could be also switched to continuous, and it can also be nominal. These are the typical modeling types used in JMP most often. And there are many other metadata types, so-called properties, you can set per column, including value colors and units, specification limits, and many more. Regarding the interactivity, there are 3 ways to work with JMP reports. Let me just call one analysis by using this script here. So this is a fit y by x output, and one way to work with this output, an interactive report in JMP, are the red triangles. So on the top red triangle, I could, for instance, add the effect summary. I could also ask for some row diagnostics, maybe the residual by predicted plot. The second way to work with these reports is a right click. So I can right click here to set a background color. But I can also right click on table outputs. For instance, on the parameter estimates, I can right click to add more information, like the variance inflation factor. I can also right click for sorting to sort this by p-value. Or I can right click and make this table into a JMP data table for further analysis or graphing. And the third way is the dynamic linking feature of all windows. So for instance, I can multi-select the taller kids, and you see that these data points are connected with all other windows and outputs and even the underlying data tables. So let's say goodbye to our big class families, and let's look into data import into JMP. So you already got some data when you install JMP, and they are available on the help menu, sample data. So there are sample data files for multivariate analyses. If you're interested in medical studies, you can look here. And there are also many examples for teaching. So most of the sample data files, like the hurricanes data file, they have some stored scripts you can just play and see what's in. So this is about hurricane data over time. So I can just run it and play it, and you can see where the hurricanes occurred during the last years and with their names and so on. That's an animated bubble plot. And you also find interactive teaching modules. So if you are teaching, for instance, confidence intervals for a population mean, you can use this interactive module. So I choose 100 samples. Here you see that the confidence level is set to 95%. I animate it and draw additional samples. And now you see the red intervals which don't include the true mean. And this is typically 4% of all the 100 of all the intervals will be red, around 5%. And here we have 4%, 4 of 100, which are shown in red, not including the true mean, which can be set here. This is just one of our interactive modules, which are nice to explore or to demonstrate basic concepts. You can also start on the File menu, create a new table, and enter data from scratch. Or if you have data in Excel already, you can also select them and copy, and then in the new data table choose Edit and Paste with column names. So this pastes the data from Excel and it maintains the metadata including the column names, and also JMP does a best guess for the modeling types. There's also an Excel import wizard or text file import wizard, which allows you a more flexible way opening Excel or CSV files. And alternatives are also to load data from databases. There's a query builder tool, so you don't have to write your SQL code. It will be done by that tool. It's a drag and drop tool, or you load data from a SAS server. A nice way is also this Internet Open. So here, JMP asks us for a URL, a web page which has some table data. And I have this example here on Wikipedia, and that's about the world population. And we see that there is a table about the 10 most populous countries with names and flags and so on. So to import this table, I just copy the URL and paste it in here. Click OK. And now I have to select the table, typically by title or some other information, and I click OK. So now there's a script which allows me to automatically load the pictures from the web page. And now I have to break this here, the name. Let me just change the formatting here. So this is character data and nominal. So now I can take this column and use a column utility and break it into pieces using the quote as the delimiter. And then I check what we got. So this is the column which got the country names. There were some footnotes for 2 countries. Let me just remove them. And I choose the flag and use this for labeling. So now I'm ready to use the data, for instance, on Graph Builder. So here I take the countries and population is what I'm interested in, what's shown in the table, and we are done. So here we see the 10 most populous countries, and we see that India and China are by far the most populous countries on that ranking, which has recent data just a few days ago. It's online data you can easily get into JMP. Okay. So now I will show you some platforms for summarizing and graphing data using another sample data set called World Demographics. So one way to explore a new data set, especially with a higher number of columns or variables, so here we have 32 columns, is the columns viewer. I can get from the columns menu. So I choose all of my columns, also show the quartiles, and ask for a summary. So now you see for all the columns the number of values, the number of missing values. So here in this data set we do have some missing values. For categorical data we also see the number of categories. So for instance we see that there's a variable development level which has 4 values, 4 categories, 4 levels actually. And now you can browse this and maybe look also for minimum, maximum, the mean, if there's anything maybe which looks strange to you. So that could be a problem, a data problem or an error. So for instance, on the GDP, we see this extremely high maximum here. So this is in thousands. So that's maybe a bit to worry about. I could ask for the distribution for this variable right here, or on the standard menu, distribution, assign it, and OK. And now we look at the distribution for GDP, and we see that there's one extremely high data point, and by pointing on that one we see, oops, that's the world, which sums up all the GDPs for all the countries. So we don't want to have this showing up here, so I select it, right click, and then hide and exclude this data point. And if you tell the report to if you tell the report to monitor the data table by automatic recalc, it does so and changes automatically as soon as the underlying data changes. So now we see that the new maximum is by the United States and the second highest value is from China. So that makes more sense. I could also change the histogram here by using the hand tool, maybe from the tools menu. That's the grabber or hand tool, and by using that one I can also change the binning, so the binning size or the binning location, so that this can be seen a bit better. I can also change the histogram by moving this here. So by far the most countries have a very low GDP, what can be also seen in the quantile information. Okay. Another tool for now I have to remove this window. Okay. Another tool is an interactive tabulation tool you can find on the Analyze menu, Tabulate. That's an interactive tool again. So here I can choose maybe the infant and the 5-year mortality rates and drag and drop them to the table. And I want to see the mean instead of the sum. So I replace the sum statistic by mean. So now we see the mean mortality rates, and I want to break them down by development level. So I add the development level for grouping our mean data. So if you want to change the formatting, you can do this here. So I just want to have fixed decimal with 2 digits behind the comma. So that's done now. And I can also add a chart to see this visually. And when I'm done, I click done, and that's the output. One generic way to save anything in JMP is to save this output, what we did so far, as a script, maybe to the data table. And by doing this, I change the name to myTabulate or any other better name probably, and click OK. And now I can close this output, maybe share this data set with others, and they will get this myTabulate script on the tables panel here and run it again, and they get back to the same report. And it's again the interactive report you can use and enhance and add more information. Maybe another variable, and dig deeper and so on. Save anything as a script to the data table or to the journal. That's really handy to save anything what's interesting and what you would like to maybe reproduce in the future. The third tool is the graph builder, not to miss, of course. We saw this earlier. So here I choose the crude death rate as the Y and the birth rate as the X. And again, I use development level to group it, or I can also wrap it or group it this way, or color, overlay. So with overlay we see 4 different smoothers per development level, and I can also change this to a line, and then we see that the relationships between death and birth rates are really different, to negative to positive for the different development levels. Let me start again, and now again I choose the death rate as the Y, but let me add the birth rate also on the Y-axis to have 2 variables here, and I break this down by development level, which I put on the X-axis now. So I switch to box plots, and now we see 4 box plots for each variable for the 4 development levels. Start over, and again we have the territory, which is the country. I can put on the map shape zone, and this gets the shapes for all the countries. And now I can drop a variable like population to show the population by country as geographic information. And again I can point to the countries, and we see India and China as with the data we just got from the web page. It's very similar what we have in our sample data set here. When you're done, again, you click done, and I maximize this. So this down here is Antarctica, where we have a missing value, so that's not colored at all. This here is Germany, with 81 million people, and I can also remove the legend because I want to show you another generic feature which is on the redo menu, and this is called column switcher. So now we are looking at population only, but the column switcher allows me to switch population by other variables and use the same output as a template. And I can walk through all my variables and look for certain patterns or anything what seems to be interesting. So here, for instance, we have the male-female ratio at birth, and you see that this is extremely high in India and China compared to the other countries for the reasons you probably know. I move on to some tips. So we already talked about the red triangles. I open an output again. So let me open this distribution GDP per capita output. And by the way, GDP per capita, so this variable has a plus sign telling you this column has a formula, so no static values, but this formula to calculate the values based on other information in our data set. And here you see the formula editor, which gives you access to many functions, especially statistical functions, to calculate anything you need for your analysis. So I call this output here to show you some tips. And for the red triangle, I mentioned that already. It cannot be emphasized too much because this is so important to check them out, because these are the context menus. Depending on the type of analysis, the type of your data, and sample size and so on, you get all the methods and tests and everything useful in that analysis context. So here for this variable I could add a cumulative distribution function, for instance. I could also look at the summary statistics. There's a red triangle, so I can customize this and add some other summary statistics to this output, and now they are added here. By the way, if you want to see these statistics by default, or if you want to change anything else and don't do it again and again on every output, you can open the preferences, and on platforms you see all the platforms including distribution summary statistics, where you can select all the statistics you want to see by default, and then you can switch them off, but you don't need to get them on the output again and again. Okay, so these are the preferences for saving your work. So we already saw how to save anything in JMP as a script, but if you want to export anything out of JMP, one way is using this distribution output, file, export, and here you see that you can use text or images. You get different image formats, HTML, a PowerPoint slide deck, and even interactive HTML. So this is an HTML5 export I do now, and that's a web page you can open in a browser, but you can also use this HTML on a web page or on a PowerPoint slide, because this is interactive. So we can close this, but it's still interactive, so I can multi-select data points. So you have some limited functionality, but still interactive functionality to work with the data without having JMP anymore. It's just a browser. For help, please refer to the help menu where you see all the books. Using JMP, basic analyses. So these are maybe some good starting points, and then there are some special books about special topics. Let me show you. Oops. Need to close the window. I open this cluster output here, so I can choose a certain number of clusters, clustering the countries by demographic data into 10 groups now. So, and I would like to copy this dendrogram into a slide or a Word document, maybe a paper. Before doing this, you can also change the title and change colors and everything. But when you're done, what you have to do is to select what you want to copy. And that's done by the selection tool, or just by pressing S for selection tool. Your cursor changes into a fat plus sign. I select this output and copy. And then in Word or PowerPoint, it's not just a paste, but a paste special. On the Mac, you choose PDF. On Windows, you use enhanced meta file. And click OK. And now we see that we have a vector graphic, which can be zoomed. And it's still high quality. And here you see that Swaziland makes up one group, one cluster, and also Afghanistan, Liberia, Zambia, Sierra Leone and others grouped together. What seems to make sense. Let me close this again. If you want to learn more about clustering and dendrograms, you can also grab the help tool or press the question mark. And then your cursor changes again into a question mark. And then you get context depending help telling you about dendrograms and clustering. You can also ask JMP, the help menu, using the statistics index about what about dendrograms and where can I find them in JMP. So here you get access to all the statistical methods and tools built into JMP, and you can open the help from here or just run an example to see an example for this method. That's the statistics index, which is also quite useful. It works like yellow pages, but that's what you typically don't need, because JMP is more data driven, and JMP gives you all the tools and the methods automatically on the red triangles. Right, so the final step is to look into some basic analyses using some car data, and I have to tidy up a bit, so we don't need this anymore. But I open another sample data set, which is called car physical data. And here we are interested in horsepower. Can we explain or even predict the horsepower of a car when we know the country, the type of the car, and the weight, the turning circle, and some other information. So that's the question here. And I would like to use 3 platforms which typically cover 98% of what you use in an introductory statistics course. And they are all on the Analyze menu, and they are Distribution Univariate, Fit Y by X for bivariate statistics, and Fit Model for modeling. So I start with distribution. I choose all the columns except model for the analysis and click OK. So now we have all the histograms and some other outputs, frequencies for categorical data, quantiles for continuous data below. And now I can just click and explore, and I can compare US and Japanese cars, and I see that the US cars on average have a higher turning circle than Japanese cars. Looking into horsepower, I can also select the cars with higher horsepower, and I see that these are more cars from the US than from Japan. They typically have a higher weight and also turning circle. And these are not the small cars, more large, medium, and sports cars. What makes sense, of course. So if you want to do a test, if you want to test for mean, that's also found on the red triangle. So here for weight, for instance, I can test for mean. I enter a hypothesized mean of 3060. Okay. And now the test is added to this output here. And we see this simple graph down here. So this is the sampling distribution of the mean. And this is the observed mean in our data. And it's quite unlikely, so here we get a p-value which is below 0.05, so this is significant. So it's not really likely to that this is the mean in our data in the population. By the way, there's also an animation. So if you test about, if you teach about the t-test, you can also use this animation here and then change the hypothesized mean and see how this changes the t-ratio, the p-value. You can also change the sample size and also see that effect. That's distribution for univariate statistics, but you can just click around and already see relationships. A 1-by-1 relationship can be studied in more detail using the Fit Y by X platform. And as you see on the launch window and also in the journal, there are 4 ways to use this platform, depending on the modeling type of the Y and the modeling type of the X. You can run into a bivariate, a one-way ANOVA, and logistic and contingency analysis. So let me show you an example or 2 examples. So I compare horsepower against type and displacement. So 1x is categorical, 1 continuous, and then we get this here. So on the left hand side, that's the continuous versus categorical case, one-way analysis. So here I can add means and an ANOVA table. So here this f-test is telling me there are some differences. I can also ask to compare the means by Tukey's HSD test, and already by color I can tell which groups are significantly different regarding their means. On the right hand side, it's the same platform but different types of data, continuous by continuous. Yeah, so here I can fit a line, and I can also add a confidence interval for that fit. I can ask for non-parametric density contours. Yeah, so there are different options because the context is a different one. So this is about a scatter plot and regression. The other two options use a categorical Y and country and horsepower as the factors. And in this case, on the left-hand side, we get a mosaic plot, a contingency table for categorical, and that's where you find the chi-square test. And on the right-hand side, that's the logistic fit. And here we can see, for instance, that if you have a horsepower of 200, there are typically no small cars anymore. So the likelihood to have a small car is almost zero at that horsepower. And finally, the last platform I would like to show you briefly is the modeling platform. I just recall the settings I used last time. So we have the horsepower, our response, to model by these model effects. I added an interaction term, displacement by country, and I built that model. We see the actual by predicted plot, an R² of 82%. I see that displacement is the most significant factor here, but the interaction is also highly significant. Not significant are weight and gas tank size. I can easily remove from the model, and we see it didn't change a lot. We still have the same R². So there's diagnostic information and more information here, but I can visualize the model using the profiler. And this is very powerful because you can see the relationships. For instance, we see that turning circle is less significant than displacement, which has a much steeper curve. So these are linear effects, but displacement is much steeper. And if you look at this here, we see that for a high displacement, the cars from the US seem to have the lowest horsepower on average. Yeah, so this is the lowest horsepower on average, but if we look at cars with a low displacement, this relationship changes. So now, on average, the US cars have the highest horsepower. So you can easily see rules and relationships like this using the model and interactively changing settings. And we can also ask for what is the car with the highest horsepower, so we can optimize our settings. In this context, it means maximizing horsepower. And by doing this, we get the answer, and the answer is down here. So the highest horsepower can be get by buying a Japanese sports car with this turning circle and so on. And then the predicted horsepower by our model will be 371 with that confidence interval down here. If you're happy with the model, if you want to use it, you can also save the prediction formula to the data table. And now the data table has this formula here, a new column. this column has this formula, so you can see the model and you can see all the parameters of our model down here, but you can also add new data, and then this formula will predict the horsepower on new cars. Okay, let me close that data table as well. So far we focused on our software which can really engage your students when teaching with data. If you watch our videos at jump.com/why, you will see more arguments to teach with JMP, including our free resources for teaching and learning. And if you look at jump.com/teach, there you will see the course material library, where you find the e-learning courses which are included in our site licenses about several topics, or training material, instructor material you can get from us and use all the data sets and the demos and examples in your own courses. There's also a best of our course collections, so introductory statistics. This one, for instance, has all the recommended one-page guides, case studies with real-world problems and data sets and solutions, some add-ins, webinars, lab activities, books, and many more resources you can get from here. So there's no greenfield if you want to use JMP in courses. Two other recommended resources are our online user community at community.jump.com to share resources and ask questions and connect with other users, and our academic industry network at jump.com/network. There you can find customer stories and more information, also information from industry. Wrapping up, on the web, jump.com, you can find more information about our products, what are the main applications in JMP. So there are also applications for design of experiments or reliability, Six Sigma. So you can see these application areas and then dig deeper and look at demos, white papers, and so on. And you can also see more users and some customer stories online. So I can maybe check who is using JMP for design of experiments, and you can look at this and get some ideas and see why JMP skills really matter for your students. For licensing, so JMP is typically used in teaching as a site license. This is called JMP Academic Suite, and it includes JMP Pro for Windows and Mac, all the e-learning courses, and much more. So if you're interested in such a license, please get in touch and we will tell you all the details you're interested to know. So today you saw the tip of the iceberg of JMP's analytical tools, which are also used for real-world problem solving in industry. And professors can teach concepts and not software. And during the next days, this journal and also the recording of this session will be published in our academic webinar library at jump.com/teach. And in case you want to try JMP, or if you need some recommendations for courses, please email academic@jump.com.